Good morning, Namaskar. My name is Suraj Singh, professional engineer, certified by the Institution of Engineers India. I've just been thinking to discuss about buildings, RCC buildings particularly. RCC building is used by mostly in residential projects, commercial projects, and various other projects where no industry is involved. And RCC buildings are given very well finishes. RCC structures, we can say, is resembles like anatomy in human body. There are certain elements that are involved for the design, construction, for the buildings, and these elements are foundations for the structures, you can say, superstructures, finishes, etc. Let us say foundations first of all. Foundations means soil, subsoil we can say. Soil is also a part of structures because there are so many structures in the soil, and it's a part of foundations because the load coming from the building structures and building finishes are received by the foundations, which in turn transfer these loads and forces to the soil below. It can be soil, it can be rock, it can be any strata within the earth crust. I'm calling crust because first 35 kilometers of the lithosphere is called crust. So don't get confused, please. It is a part of earth. Soil engineering is very complicated part of building designs, and it involves a lot of investigation, exploration, thoughts, research on that, and a combination of soil engineer, geotechnical engineer, tomographical engineer, civil engineer, structural engineer, they conceive to a decision regarding what type of foundation should be selected for a particular type of building. After taking that decision, the design starts, but before taking that decision, a vast work is done for the exploration. It depends upon the size of the building. It's one building, it's a small building, it's a spread building, it's a tall building, or it's a complex. Soil investigation involves a lot of requirements, a lot of specifications, but it depends on what type of investigation engineer proceeds and requests the soil laboratory to carry out that. After getting complete feedback from the geotechnical engineers, civil engineers, or architects, or structural engineers, or in combination, they reach a decision about the type of the foundation, which can be simple split footings, which can be simple rafts, which can be simple beams in the foundations, or which can be piles, or a combination of these. This discussion is just to apprise the people as well as freshers in engineering to know about the field practice, how it is done. All seniors, all professors, they are well aware about this. This is just to make people aware about this. It's not very specialist lecture I'm giving. This is an ordinary discussion. This should be known to all involved in construction, in construction business, in contracting, in promotion, etc. Important part in foundations is that it takes a lot of time. Even machines are involved. Backfilling is very important item in this. Foundation construction is also very important. And then next step after completion of structures in foundation takes us to flooring in ground or grade, and then work of superstructure is started, and that superstructure, according to my thought, basement is also superstructure in this case, though it is below surface level or it is below finished ground level or grade level, but let us see it's a part of superstructure. The work from there starts, which includes columns, that includes shear walls, it includes many other aspects. For example, cores in some cases, lift walls. The construction of that takes time, and say for a small building up to say 1 story, 2 story, or 2.5 story, where our houses are built on plots. Spans are kept around 5 meters. In some cases where big houses are there, it is taken up to 11 meters, 12 meters. And a number of columns are erected. Big columns. I'm not talking about 30 centimeter by 30 centimeter column or 9 inches by 9 inches column. I'm talking good size of columns, say 400 by 400 or 400 by 600 mm or 400 by 500 mm or 400 by 1000 mm, depending upon the span building is involved with. Then, after pouring these columns, the work of suspended slab starts. Suspended slab, I mean to say, the monolithic casting of the slab and beams and the small part of column heads. That is called suspended slab in construction. And that work is very much time consuming, and various forms are erected for that. And generally the material used nowadays is 12 mm or 18 mm ply, that is waterproof ply, a red color you can say. That ply used along with timber battens of 2 inches by 3 inches size or 50 by 75 mm size in section, or more than that also are used. These provide good supporting system to the slab bottom, and these are further supported by either props or by standard scaffolding system. Or in various places, bullies are also used, timber bullies we can say, which is I don't like that much because it's not preferable, but people do that. This takes a lot of time in the preparatory work of slabs. This preparatory work should be well designed from keeping in view the safety angle, because safety is very important. Anybody can fall from any height. Generally, the height of one floor is 3.5 meters. Say, there are chances the people working on it can fall, and we have to maintain railing, temporary railing around so that people should work safely. This is what is very complicated work, and labels and lines and alignments all are to be checked. On that, reinforcement bars are to be placed according to design. Concrete covers are to be provided below the reinforcement bars. In that, electric ducts are also placed, or electric conduits you can say. Other openings for the plumbing work and air conditioning works are also fixed in like blockouts. And then, after complete inspection, the program for the pouring is decided, and pouring is done either by manual mixing on site by weigh batcher, or getting complete supply from the batching plant through truck mixers, and using the mobile pumps or stationary reciprocating pumps for pouring in, or using some crane, mobile crane with the bucket or skip to transport the concrete from the delivery point to the point of placement. This is a general statement I am giving. And most important thing in construction of RCC is the curing. Curing part is very important, which is generally neglected by general public and even the contractors or the builders. Curing is very important because without curing, concrete is nothing but like ordinary sand or ordinary aggregate. It doesn't work. So the metal will not gain the strength, and it is of no use. So in case of M30 concrete, you get just M10 or M15 without curing. The curing is very significant, and all guys on site should care for that. Otherwise, it's no use. Your money is wasted. Building is wasted. There's no resistance to forces. And I conclude this small lecture here, a small discussion here, because this video will not allow more than 10 minutes on this YouTube. So, excuse me, in the next one, we'll discuss later on. Thank you very much for your attention. Suraj saying thanks. Bye.